Okay, we're live. Good morning, good morning, good morning. I know it's a little bit early. Thank you for joining me. We have 3 viewers out there. Good morning, good morning. Wait, it's a little bit early. Welcome to the class. Seems like people are going in and out. But, yeah, everything's out there. Okay. Maybe it's just too early. Although it shouldn't be. Maybe we're waiting for 9 on the dot. So, we have time. I have time to think about what to write on the whiteboard. It's a good word. I think I know what word I'm going to choose. Yes. All right, this is the word of the day. The word is live. Okay. Let's see who's out there. One viewer out there right now. Good morning, Leanna. Good morning, Sarah. The board is up. Word of the day is up. Please make sure that the board is operational. Oh, yes. It should be plural, though, right? Because you need sticks. That's right. That's right. I only say that because I have in my dining room, like kitchen area, I have a fork and a spoon on the wall. Like they're pretty large, and I could have written spoon, I could have written fork, but it's kind of boring. So there you go. That's why I thought of chopstick, and also I thought about uh, you know one of the best places I ever visited, and um, yeah, that was Japan. Oh, it was so good. I think about that place almost every day. Very magical. I highly recommend that once this is all over and you can fly freely and, with ease, mental ease, I recommend that you go there. And also, the Olympics are going to take place next year, so why not? And the sad thing was right before I left Japan, I was in the airport, and it was, I don't know, just like some general like souvenir shop or whatever. And right at the counter, they had a Japan 2020 Olympics or Tokyo 2020 Olympics keychain thing, and I bought it. So now I have that to look at and think of what could have been. But it's all right. 2021. Is everyone doing well out there? How are your classes going? Believe it or not, the DOE finally approved Zoom classes, and I thought about doing Zoom classes with everyone uh, in this class, but to get people set up, and then it's almost as if they were discouraging video for whatever reason, and like I just thought, like, you know what, I don't want to deal with that. I think we're fine here. The only sad thing is that, or disappointing thing I should say, is that I can't hear any of your voices. Like I'm very dependent on the live chat, and it's okay, but I don't know. You kind of lose some of that human quality to teaching. I mean, you can make it more animated, right? Oh, how'd that go? AP test. Which one was the first test? I forget. So, hi, yes, you all are preparing for the AP exam. That's right. Is it easier, more difficult? I know it's 45 minutes. So how was it taking an AP exam online and for it to be 45 minutes in length? AP Gov. It was really weird. Interesting. It was timed, I think, right? So when the exam opened, I guess at the end of it, like the 45-minute mark, it just shuts down, I'm guessing. And it's all short response, right? It was easier in my opinion. Good. I thought it would be easier, but it wasn't really. Okay. It was very fair. Got it. Well, I hope you all got fives. I mean, what, you have like one shot? Like, right, is it one question with multiple parts? So I don't really know the specifics of the AP exam. I know that it's short answer, but I'm not sure if it was broken up into parts, and I'm sure you had some documents to look at, and uh, I'm sure navigating it was, somewhat unique. But again, I hope you all got five. Yeah, you can't submit work after the time is up. Okay. I wonder if it automatically submits what you have, because I know that I've taken many exams online where it's timed and the clock is there. Is a clock there counting down the time? See, so if you're not used to that, that increases the stakes. That kind of like, I think that creates true, anxiety in taking exams, seeing that clock. Two questions, one is an argumentative response and the other is like a short response. Okay. Yeah, but it's all written. So my question to you, so to those out there, um, is there a timer? And does that timer deplete? Like, do you see like 45 minutes, then 44, then 43? Oh, that's terrible. Yeah, countdown. Ooh. So, taking an exam is, really anxiety inducing. It can be. You need to copy and paste from another document. You can't write in the test. That's kind of silly. That's very silly. I can find other adjectives to use, but we'll stick with silly. Okay. Well, I hope you did well. Welcome to taking exams online with the countdown. You'll get used to it, but it's not going to take away from the fact that it could cause slight anxiety, right? Get nervous, all of these thoughts, and yeah, the timer is there. Lucky for you, with me, like I've always been, somewhat flexible with timing. I understand, but now, like in this generation or this era of testing and so forth, that might be the new norm. So, you know, get used to that, I suppose. All right. So, let's see. So the homework was posted, although I think it was assigned a little bit later in the afternoon slash evening. So my apologies. So when that does happen again, yesterday was just such a crazy day for me. So where was I? Let me just open this. Okay. All right. So I did assign homework, but that homework is going to be due tonight by midnight. So it was assigned. So don't worry about submitting it like in an hour or whatever it is you have until midnight. And whatever homework I assign today, that'll be due on Friday. But if you need extra time, I could also give that to you for this assignment as well. Just let me know. I'm not going to penalize you. All right, but moving along. So today is AP Calc. That much I do know. I imagine that there could be lighter attendance this week or the next week and a half just because of these AP exams, although they are only 45 minutes, so that is one of the benefits. So let's keep this moving. Let's not waste time. So we're looking at a few things in this chapter. There's a graphic. You probably saw that yesterday, but I can look into it or read a little bit of what it says if it's too hard to see. It says a horse walks into a bar and says, on a right angle triangle with sides x, y, and z. If x and z are perpendicular, which side is opposite the right angle? The barman says, y, the long face. I hope you like that one. I hope you like that one. And horses are awesome, by the way. Anyway, so I actually have a selfie with a horse. Maybe I should post it one day. You have to remind me though. I won't do it unless I get, high reminders and high requests. Anyway, so continuing along. So right triangle based definitions of the trigonometric functions, cofunctions, trigonometric function values of special angles. There's some reference angles also. Special angles as reference angles. There's a lot of stuff happening, right? You'll definitely need a calculator at some point, so hopefully you downloaded the software. If you don't have a graphing calculator, you use the code or whatever special code that was given for free usage for 6 months. And then we're going to look at finding angle measures. So just some basics here. We already covered this in the previous section. So again, right triangles, the angle in question, typically an acute angle, which is why when we were in the quadrants and the terminal side, it was in like quadrant 2 or 3. The angle appeared obtuse and or reflex, greater than 180, less than 360. However, we would always refer to an acute angle when we were dealing with these right triangles. So again, this is just a quick refresher. Remember SOHCAHTOA and then the reciprocal or the cofunctions for the original sine, cosine, and tangent functions. So if we look, we don't really need to spend too much time. Let's look at the handout for today, going to the stream or the classwork section. So we should be looking at our learning materials. Within the learning materials, I believe we will be looking at special right triangles and reference angles. So that handout. So again, the handout on the top right-hand side, it says special right triangles and reference angles. So please access or locate that. Okay, so let's begin. So if you look at the first question, it's really not that difficult of a question. It's just a quick review. It could almost be like a warm-up. So if you haven't done so, let's just find sine, cosine, tangent for both of these angles. So we'll do angle A. I'll do two arcs on angle B, and we have the following. You don't even have to find the side lengths. It's just more of a warm-up, I suppose. So I'm going to give you 1 minute to locate sine of A, cosine of A, tan of A. You can probably do this all mentally, which is great. I also would recommend that you do the same for angle B. So sine, cosine, tangent of angle B. Thirty more seconds. Let's get warmed up. So while you get warmed up, let's see what's going on in the chat or the board or stream. Let's see where people want to go. Australia and Spain. Nice. Spain and Iceland. I hear nice things about Iceland. Not so much about the food, but the landscape, the scenery, the environment is very nice. Japan and Iceland. So Iceland, Norway, and Italy. Very cool. I want to visit Greece and Spain. Spain is awesome. Maryland and Canada. Nice. Maryland you can drive to, which is nice, and also Canada, so you don't have to hop on a plane for that. Cece wants to go to Iceland. Nice. What's up with Iceland? Is that like the go-to place now? But apparently it's really, really cool. It doesn't take that long to get to. I think maybe like 5 hours and change. Hawaii and France. I definitely want to go to Hawaii. France and North Carolina. Very cool. Italy and Hawaii. France and Albania. Nice. I want to visit Argentina and Spain. I'd love to go to Argentina. I hear great things and very, very good food. Singapore, very nice. And Germany. Yeah, I would like to go there. Definitely Singapore. Definitely want to visit more of Asia. Anyway, let's see, where were we? So going back here, hopefully you warmed up. You found those very quickly, so they were really not too difficult. So here's sine of A. So just review your notes. Remember opposite, hypotenuse, your labeling with respect to the angles. And if we look at sine, cosine, tangent of B, we have the following. So some things to think about. So again, we have additional identities. Some of these were described in your prior classes, especially the relationship between the sine of an angle and the cosine of the complement of that angle. So in other words, if we're looking here, and you can see the work that you did. So if you reviewed the work for the sine of A, that should equal to the cosine of B. If you looked at the work for the cosine of A, that should have equal to the sine of B. Because again, A and B in this case should be complementary, or when you add them together, they equal to 90 degrees. So here's some relationships. So again, sine of A, essentially then cosine of 90 minus A, which is in this case the other acute angle. And there are other relationships as well. The more popular ones are the top cases, but these are additional identities. And similarly, you can see that here in the graphic, and it's more evident when you're looking at the ratios. So if you're looking at this triangle with respect to angle A, you know the sine, right, y over r, but if you look at cosine of B, the adjacent side ends up being y. So if you compare adjacent to hypotenuse for B, that's the same as opposite to hypotenuse for A. So that's why those relationships exist. So what I want us to do, if we look at the next example, so what we have is the cosine of 52 degrees. So what we want to do is we want to find an equivalent trigonometric ratio or trigonometric function with the angle. So we know that cosine and sine share a relationship, but really if we analyze the angle, so hopefully you're looking at the board, because I've been writing there now for some time. What we want is for these angles, when added together, to equal to 90 degrees. So hopefully you found that the complement for 52 degrees, in this case, would be 38 degrees. And you can use a calculator also. So what I would do if I were you, I would put cosine of 52 in the calculator, hit enter, and then I would do sine of 38, put that on the calculator, hit enter, and they should be identical values. And if you do that, looking, I'm going to do that also on my calculator. I'm just using my iPhone calculator, because I don't have the... Actually, I could open up my TI-84, the real one, but it's all right. Maybe I'm lazy today. So it should be about 0.62 if you do for both. So cosine of 52, yeah, about 0.62. All right, so now we have to look at tangent. So if we look at tangent, so tangent has a relationship with cotangent. So in this case, we're going to look for, again, the complement of 71 degrees. So in other words, what two angles or in this case, what angle adds with 71 to give you 90? So that's what you're really looking for here. And if we do that, that should easily be 19. But now here's the issue. How do you type cotangent of 19 degrees? I don't believe the calculators that we have do that. I mean, they might be embedded within the calculator, but you can easily do the following. So if you're still looking at the board, what I would do if I were you, I would do 1 divided by tan of 19 degrees. Hit enter, and then do tan of 71 degrees. and they should equal to one another. And I'll do that now as well. So let's see, we have 1 divided by tan of 19. That should be about 2.9. And then tan of 71 is the same. So then lastly, if you look here, secant. So again, secant has a relationship to here, 24 degrees. It's going to have a relationship with the cofunction, cosecant in this case. And again, the relationship is going to be that these angles are complementary. So when we find the difference with 90, it should be 66 degrees. So one of the challenges here is how you write secant, right? So again, the question is this: secant, does it relate to sine or cosine? Right? So think about that 10, 15 seconds. Secant, is it attached to sine or cosine? So that's what we want to figure out, because this has to be 1 divided by some angle or some trig function, right? This is also going to be 1 divided by some trig function. So hopefully you recognize that that was cosine and that this was sine. And if you put this into the calculator, they should equal to one another. So let's do that quickly. Again, using your calculator. So we have 1 divided by 24 cosine. I have about 1.1, and 1 divided by sine of 66 degrees. I also have about 1.1. So hopefully you were able to confirm that, and this is all here. So you can review that. Just take a moment to look. Okay. All right. So let's move along. So we're going to look at now special right triangles. So you've done this already in the past, but we're going to do a quick refresher. So we have 30, 60, 90, and we have 45, 45, 90. So what I like about 45, 45, 90, it's, we can think of it in terms of a right or an isosceles right triangle. Right, so you have the triangle in front of you, you're looking. Let's see. If you're really looking, I'm testing you. What side lengths did I just put on? Because I've never asked if you're, following along with me. So let's see. What side lengths just went up on this triangle? I'm testing you guys now. Where is the chat? Okay. What side lengths did I just put on this triangle that I'm working with? So again, what side lengths are on the triangle that I just drew on the board? Thank you, Leah. Thank you. Thank you. Very, very good. You get one of these. I wonder if I can do at. Yes, I can. Great. And at. Here we go. There you go. Hopefully you saw that and you enjoyed it. All right, so we have 8, yes, 8 by 8. So here we go. So again, this is going to be isosceles right triangle. Don't forget, quick review of geometry. When we have an isosceles triangle, the angles opposite the congruent sides are also congruent. So, and if we have, I'm going to call this x, if we have 3 angles in this triangle, right, we add them all together, including 90, right? So this all equals to 180, right? We solve 90, x must be 45, so we have 45, 45, 90. So I'm going to call this side length here y, and we're going to solve for y. We'll do this quickly. Remember, 8 squared plus 8 squared equals to y squared. So this becomes what here? 64 plus 64. 128 equals y squared. But if you take the square root, this becomes radical 64 radical 2, or 8 radical 2 equals to y. So in other words, the rules for 45, 45, 90. So if we look at the triangle, I'm redrawing one, right? If we know that one side length is x, or the legs are congruent, right? Then the length of the hypotenuse will always be radical 2 times larger. It will always be radical 2 times larger than the leg. So again, that's the hypotenuse. A little bit difficult or different with the equilateral triangle. So if we look here, equilateral, I don't know, it's drawn poorly. Let's see, let's go with 10, why not? So each side length is 10. I'm going to draw this. Let's see, I'm drawing this piece here. What's the name of this piece that I'm drawing right now? That purple segment. Let's see who's out there who could identify that. I'm waiting. Let's see who can identify what that purple segment is with that symbol. What is the name of that? Remember the name of that segment. "30 more seconds to try to come up with the name of that purple segment that I drew that doesn't look that nice, but I think the point will be made or is made. So what is the name? "10 more seconds. Okay, it's all right if we forgot. It's an altitude. An altitude. So in an median, it could be. It could be. It could be all those things, Leah. Thank you. I just saw that now. I like it. It could be that because this is a special case. And because the word of the day was chopsticks, and for whatever reason this emoji thing is here, you're going to get one of these. Let's see. Hold on. You get one of these. Just because it's the word of the day. Or how we started the class. Alrighty. Thank you for that, Leah. But yes, in an equilateral triangle, this segment, it could be a median. It acts as a bisector, but it's really an altitude. That at the most superficial level. But it will cut the base in half. So we have this, right? But it's also going to cut the angle in half. So the angle gets cut in half up there. But if it's going to get cut in half, then we have here, look, this is 60. Oops. Here we have 60. Here we have 60. But the bisector, as Leah correctly identified, will cut that angle at the apex or the peak, or the vertex, if you will, it's going to be cut in half. So 60 gets cut into 30 and 30, and I'm going to redraw this triangle now so that it's split up properly. So you basically have this. This is 10, this is 5, and this is 30, 60. Solving for x, we have 10 squared equals to 5 squared plus x squared. 100 equals to 25 plus x squared. This becomes 75 equals x squared. But you take the square root, it becomes radical 25, radical 3, or 5 radical 3. So in other words, this leg, the longer leg, so this is where it's a little bit different. The longer leg of this right triangle, or opposite the 60-degree angle, will be radical 3 times larger than the smallest side, or smallest leg in the right triangle. So notice in this triangle, the smallest leg is 5. So the larger leg will be 5 times radical 3. And also something to note, that the hypotenuse will always be double the length of the smallest side. So in this case, the smallest side is 5. We double it, and we get the length of the hypotenuse. So hopefully that was a little bit clear. Hopefully some of us had that aha moment. And let's move along. So that's 30, 60, 90, 45, 45, 90 in a nutshell. And again, this is kind of going into it a little bit more. Basically what we discussed, right? The equilateral triangle, this altitude, cutting the base in half, and then we solve for x, applying Pythagorean theorem. That's why x is radical 3 times larger than the smallest side. Similarly here, I think this is kind of going into the class work section or the guided practice of the handout. But in an effort to save time, if we have this 45, 45, 90 right triangle, and each side length is 1, or the legs, then the hypotenuse is just radical 2, or 1 radical 2. Always radical 2 times larger than the leg. So I would give you typically time to try this stuff. Maybe some of you already went ahead, which is great. I'm not too concerned with number 1. I think that you can do very easily. Number 2, that could give you some difficulty, maybe, but I think it's on the easier side. And 3, we just went over those examples. So I'll let you digest that, process that for about a minute, and then I'm going to post the solutions so that you can work on that independently. Or maybe some of you are already working on that now. So just take a moment to look. Excuse me. So again, just in an effort to save time, I'll give you these solutions. So number 4 is interesting because that involves some knowledge of radian measure, which we spoke about at the beginning of this chapter. We also have going between radians and degrees, but then also how that applies with these right triangles. So what's going to happen is this, that triangles that have 30, 60, 90, or 45, 45, 90, regardless of the length, they're going to be similar. So they're going to maintain these ratios of, let's say, 1 to 1 to radical 2, or 1 to radical 3 to 2. So that's why in this chart you see 1, or like for example sine 30, you see that that's half, right? Because if you look here, let me redraw one triangle. I'm back here on the board. So we saw that we had a 30, 60, 90 triangle. That was 10, 5, and then this was 5 radical 3. This is 30. But if you think about it, the sine of 30 is opposite, which is 5, divided by the hypotenuse, which is 10. But what's 5 divided by 10? Half. So this ratio, it doesn't really matter what the side lengths are in these triangles, because triangles, again, that exhibit these angle measures are going to be similar. And if two triangles are similar, then their corresponding sides are in proportion. So that's why we have 5 divided by 10, but that's the same as 1 divided by 2. And we already looked at these. We did in various scenarios or situations where we had to rationalize the denominator, so I'm not too concerned with this. Let's see. All right, so if we move on, it says here, find the 6 trigonometric function values for a 60-degree angle. So hold on, I think this is after the fact. Just give me 1 second. Yes. Let me just look at what we have. Hold on 1 second. Just going to the stream right now. Okay. I see. No, oh, so I just aided you. I see. Find the exact value for the given lengths. Yes, we did that. Okay, complete. All right. Find the reference angle for an angle of 218 degrees. So we're going to move along. So what is a reference angle? So a reference angle, which we spoke about just before. So when we were working in the coordinate plane, again, we had obtuse angles, we had reflex angles, angles that are greater than 180 but less than 360. But in order to find the side lengths for these right triangles, we couldn't use the obtuse angle. We had to use a not similar, but a related angle, or an angle that has a working relationship with a given angle. So in this case, we call that the reference angle. So reference angle for an angle theta is the positive acute angle made by the terminal side of angle theta and the x-axis. So just look at those examples right now. So in quadrant 2, you have this blue angle, which is obtuse clearly, but then the purple angle is that leftover of 180, and that's the angle that we use in order to find the side lengths or the relationships. Sorry about that. So again, look also in quadrant 3. Sorry, just give me 1 second. Just have to. One second. Sorry about that. Okay. Alrighty, so, excuse me. So going back to this, so we have theta, again in quadrant 3, it is, if you look, this is clearly an angle that's greater than 180, but if we take the difference to the x-axis, we have this purple angle, which will be acute. And similarly, the same thing happens in quadrant 4. The angle that's closest to the x-axis from the terminal side will be acute. So if we have this 218 degree angle, so we're looking here, 218 degrees, if we sketch it quickly, on the coordinate plane. It's greater than 180, less than 270, so it's going to be somewhere here, right? So this whole thing will be 218 degrees. But what we care about is this piece here. So this red piece. So this difference. So if we consider that, then all we have to do is subtract 180. And then we end up with our reference angle, which is 38 degrees. So again, it's going to help, or it may help to sketch a coordinate plane and then to show where the terminal side is, so that this way you can see where this reference angle is, 1 and 2, the value of the reference angle. If we look at B, so it's kind of crazy to draw this, right? Because we have an angle measure that's 1,387 degrees. So what we need to do is basically figure out how many complete rotations we have, right, around the origin, if you will. So what we can do is we can divide, right, this degree measure by 360 degrees. And if we do that, we'll have roughly 3.9, I believe. So that means that there's 3 complete rotations and there's this remainder. So if we do that, we would do 1,387 minus 3 times 360, and that's going to leave us with about 307 degrees. So if that's the case, then when we look at this as one revolution, right, again, this is 307 degrees, that's this angle measure here, 307. But what we care about is this difference here. What is this measure? So that's going to be our theta. And really the only way to do that then is to take 360 and subtract that from, or by 307, excuse me. And then clearly that's going to leave us with an angle measure of 53 degrees, excuse me. So this is what it would look like. So hopefully finding reference angles isn't too challenging. Obviously it's going to be challenging when, or slightly challenging if it's greater than 360 degrees. Probably more of a challenge when it's greater than 720, maybe. But I think, once you're, above 360, then you have to think about complete revolutions and all that stuff, and it could become a challenge, but just some things to consider, or I guess some rules that you can apply. So here we have quadrant 1, 2, 3, and 4. So that's, again, clarified, highlighted. And again, this leftover angle in each scenario, we're looking for the acute angle, and that will help us find, again, particular values in a right triangle using trigonometry, because it's important that we use these acute angles in evaluating trigonometric functions. So let's see here. We're almost at that time, but I just want to walk you through this last example here. So it says here, find the values of the 6 trigonometric functions for 210 degrees. So if we're back here at our coordinate plane, here's 210. Remember, between 180 and 270, so we're in quadrant 3. We have this left over, so this is what we're going to do, right? We have to find the difference between 210 and 180. Luckily, that's 30 degrees. So if that's the case, right, what we need to do is we're going to do this. So we can find everything in terms of 30 degrees, right? But if we have All right, so this is what it's going to look like. So here's 30 degrees. That makes this 60, and then we have a 30, 60, 90. So if that's the case, remember, we are in quadrant 3. Don't forget that we are in quadrant 3. So if we look at this, certain things are going to be positive, certain things are going to be negative. So remember, keep this ratio in mind. Opposite, right? The shortest side is 1. Opposite the largest side, negative. In this case, it's going to be negative radical 3 because we are in quadrant 3. And then the hypotenuse will be 2. So if that's the case, you can find not the sine of 30, you use that, but you find the sine of 210 degrees. So according to this, this should be the same. And if we do that correctly, it should be 1/2, right? But it's not just positive 1 here, it's negative 1 because we are in a negative quadrant. So the sine of 30 or the sine of 210 will be negative 1/2. And I'm just going to show this to you here. So if you did everything correctly, you would follow this approach here. And this is where it gets a little bit of a challenge, that's for sure. It becomes a little bit more difficult because now you're thinking about the special right triangles, you're thinking about the locations of, or where you are in the quadrants, whether that's 1, 2, 3, or 4, and then the signs that are affiliated in each of those quadrants for the specific trigonometric function. So this is where we're going to stop. We did a lot today. Hopefully you're still there with me. Let's see, are there any questions out there? There's no questions. For now, at least. But do you have any questions moving along or as we, move ahead? Just some things, again, I guess you can think about. I haven't received word about the final exam date yet. I know that it's coming. You have your final review sheet. For homework tonight, let me assign that now. I'm going to do 2 things. So if you're still there, please hang out. It's going to take me another minute or so. So I'm going to go back to our classwork section. So the homework, a lot of you already turned it in, which is, I believe, let me see here. Okay. Only one of you turned it in, which is okay. So I'm going to change the due date for tomorrow because I signed this a little bit late yesterday formally, so I'm going to give you more time for that. The homework for today, hold on. Actually, it's going to be from here. Let's do it from here. Hold on. This will be the homework. So we'll look at these. You can definitely answer 1 and 2, but please complete 3 and 4 as well. And you can refer to your notes for this. So this will be the homework. I'll post it in our stream or our classwork section so that this way you have it. And this will be due on Friday. Any questions before we finish today? All right, if there are no questions, then I leave you with, I guess, just the following. You have an AP exam this week or next week, next coming days. Good luck. Study, study. Hang in there. We're getting through this. We're almost done. Just a few more weeks, and then we'll be finished with college now. So I just need you now more than ever to continue doing the hard work that you're doing. Note that if you continue in the way that you have, I think you're going to be okay. So just complete the assignments, stay in tune with whatever I'm sharing, and I think we're going to end on a positive note. So with that, good luck with your studying. If you have AP exams either today, maybe today, tomorrow, Thursday, but if not, I will see you on Friday. Have a great day. See you later.